Identifying confounders with regression in SPSS. Let us try to predict a person's average newspaper reading time from her age, education, and use of news sites. More specifically, let's find out whether predictors confound the effect of other predictors. We can do this by adding the predictors one by one to the regression model. In SPSS, we can use the linear regression command to this purpose. We select reading time as the outcome or dependent variable, and then we select one of the predictors as the independent variable. Then we press the next button and we create a new block of predictors where we add the next predictor, education, and again next to create a third block which includes the age predictor. In this way we tell SPSS to include each predictor step by step in the regression model. Now in addition, we would like to have the confidence intervals. We ought to check the assumptions for regression analysis with some plots, but this is discussed in another video, so let's skip that. Let's paste and run, and here is the output. SPSS has estimated 3 regression models for us, and the models are summarized in the first table. The first model only contains news sites used as a predictor, the second one adds education, and the third one adds age. Now each of those models has a particular model fit, an R-square value, and we can see in the second table that model 1 already explains more than 70% of the variance in newspaper reading time. So this is a very good predictor. The second model predicts average reading time hardly better, but the third model, including age, has a better prediction of about 8 percentage points. Now these model fit results do not tell us about confounding. We have to go to the coefficients table. For each model, the regression coefficients are estimated for the predictors that are included in that model. The first model is a simple regression model. It only contains news sites used as a predictor. It has a negative predictive effect on average newspaper reading time of -5.7. The second model, education level, is added, and we see that the negative effect of news sites use has slightly increased to -5.8. Now if we have a look at the confidence interval, we see that it is so wide that we really should not make anything out of this very small change. However, if the effect becomes more strongly negative or positive when a new predictor is added, that predictor was a confounder and more specifically a suppressor in the previous model. So education suppressed the news site use effect perhaps a little bit in the first model. Now let's turn to the third model, which adds age as a predictor. Now we see that the effects of news site use and education level have decreased a lot. The effect of news site use has decreased from -5.8 to -1.3, and the effect of education level has decreased from 0.46 to 0.18. If effects become weaker when a predictor is added to the model, the new predictor was a confounder, a reinforcer. The estimated effects in the model without this confounder were partly spurious. Quite a large part of the effects of news site use and education level in model 2 actually were effects of age. Comparing the coefficients between models, we can see this. We can find out which predictors were confounders.